Let us learn and enjoy. Our lesson for today is about logarithmic inequalities.
What you need to know. At the end of the lesson, the learners will be able to solve logarithmic inequalities. What's new? Logarithmic inequalities are inequalities in which one or both sides contain a logarithm. Properties of logarithmic inequalities. Number 1. If b is between 0 and 1, and logarithm base b of x sub 1 is greater than logarithm base b of x sub 2, then x sub 1 is less than x sub 2. If the base is greater than 0 but less than 1, reverse the inequality symbol. Number 2. If b is greater than 1 and logarithm base b of x sub 1 is less than logarithm base b of x sub 2, then x sub 1 is less than x sub 2. If the base is greater than 1, you have to retain the inequality symbol. Take note of the rules for solving inequalities. Number 1. Adding a real number to both sides retains the inequality. Number 2. Multiplying both sides by a positive number retains the inequality. Number 3. Multiplying both sides by a negative number reverses the inequality. This means less than changes to greater than and vice versa. Let's have some examples. Number 1. Logarithm base 3 of x is less than or equal to 5. Since the base is 3, which is greater than 1, the direction of the inequality is retained. X is greater than 0. This will be the boundary. Next, let us change logarithmic equation to exponential form. So this will become x is less than or equal to 3 raised to 5. Evaluate 3 raised to 5. We all know that 3 raised to 5 is equal to 243. So we will replace 3 raised to 5 to 243. So x now is less than or equal to 243. Let us now compare the inequalities and determine if the boundary is needed for the inequality solution. You can use illustration if you want to visualize the solution set. Take note that 0 is not included while 243 is included in the solution. Always remember that if the inequality symbol is less than or greater than, we will use parentheses. And if the inequality symbol is less than or equal to or greater than or equal to, we will use bracket. Therefore, the solution set is 0 up to 243. Take note that 0 is not included, so we will use parentheses and we will use bracket for 243 because this number is included in the solution. Number 2. Logarithm base 4 of x is greater than or equal to 6. Since the base is 4, which is greater than 1, the direction of the inequality is retained. For the boundary, we have x is greater than 0. Number 2. Logarithm base 4 of x is greater than or equal to 6. Since the base is 4, which is greater than 1, the direction of the inequality is retained. For the boundary, we have x is greater than 0. Let us now change logarithmic equation to exponential form. X is greater than or equal to 4 raised to 6. Let us evaluate 4 raised to 6. So this will become x is greater than or equal to 4096. Compare the inequalities and determine if the boundary is needed for the inequality solution. Again, you can use illustration if you want to picture the solution set. Take note that 0 is not included while 4096 is included in the solution. Take note also that we use parentheses for less than or greater than symbols and bracket for less than or equal to or greater than or equal to. Therefore, the solution set is 4096 to infinity. Note that 4096 is included, so we will use brackets and we will use parentheses for infinity. Number 3, logarithm base 6 of x plus 8 is less than or equal to 2. Since the base is 6, which is greater than 1, the direction of the inequality is retained. X plus 8 is greater than 0 for the boundary, so let us solve for x. So the boundary is when x is greater than negative 8. Next, let us change logarithmic equation to exponential form. So we have x plus 8 is less than or equal to 6 squared. Evaluate 6 squared, so we will replace it to 36. So we have x plus 8 is less than or equal to 36. To solve for x, let us add negative 8 to both sides of the inequality. So we have x is less than or equal to 28. Compare the inequalities and determine if the boundary is needed for the inequality solution. Again, if you want to use illustration to picture the solution set, take note that negative 8 is not included, so we will use a hollow circle, while positive 28 is included in the solution set, so we will use a shaded circle. Take note also that we use parentheses for less than or greater than symbols and brackets for less than or equal to or greater than or equal to. Therefore, the solution set is from negative 8 to positive 28. Take note also that we use parentheses for negative 8 because it is not included in the solution, and we use brackets for positive 28, which is included in the solution. Number 4, logarithm base 3 of 2x minus 1 is greater than logarithm base 3 of x plus 2. Since the base is 3, which is greater than 1, the direction of the inequality is retained. For the boundaries, we have 2x minus 1 is greater than 0 and x plus 2 is greater than 0. Let us solve for x to find the boundaries. So we have when x is greater than 1/2 and when x is greater than negative 2. Take note that if logarithm base b of m is equal to logarithm base b of n, then m will be equal to n. So we have 2x minus 1 is greater than x plus 2. To solve for x, let us add negative x plus 1 to each side. So we have x is greater than 3. Compare the inequalities and determine if the boundary is needed for the inequality solution. Again, if you want to use illustration to picture the solution set, take note that all solution carries a greater than symbol, which indicate that positive 3, 1/2, and negative 2 are not included in the solution, so we will use parentheses. Therefore, the solution set is from positive 3 to infinity. Number 5, logarithm base 1/5 of x is greater than logarithm base 1/5 of 1/5 raised to negative 3. Since the base is 1/5, which is not greater than 1, the direction of the inequality will be reversed. X is greater than 0 for the boundary. Take note that if logarithm base b of m is equal to logarithm base b of n, then m is equal to n. Therefore, x is less than 1/5 raised to 1/3. Evaluate 1/5 raised to negative 3, so we have 125. So this will become x is less than 125. Compare the inequalities and determine if the boundary is needed for the inequality solution. So the solution will be from 0 up to 125. We will use parentheses because both of the solution are not included. What you need to remember: logarithmic inequalities are inequalities in which one or both sides contain a logarithm. The properties of logarithmic inequalities and the rules for solving inequalities.
See you in our next video. Have a good day!